his extraordinary dedication and passion in the field of civil engineering and structural design. And his Kalamsari and Noel Tall Terrace, Kochi has won ICI Ultratech Award for Outstanding Concrete Structures in Kerala in the building category in many years, continuously 2012, 2017, 2018, 2020, and 2025. Ultratech ICI Award has come to him. He was also honored in 2026 with special award recognizing his outstanding dedication and professional expertise for the V-Guard Innovation Campus in Kinfra, Kakinad. He is the Managing Director of Seacons Private Limited, a construction firm specialized in execution of pile foundations, and also Director of Engineers Diagnostic Center Private Limited, a firm specialized in geotechnical investigation and retrofitting works. He had done his post-graduation in civil engineering from SVNIT Surat and has completed his PhD in pre-compression and soft marine clays in NIT Calcutta. His passion towards civil engineering and motto to serve the country made him win many positions in professional bodies such as Vice President Asia International Society of Soil Mechanics and Geotechnical Engineering for the term 26 to 30, President of Indian Geotechnical Society for the term 23 to 26, Chairman of Indian Buildings Congress Kerala chapter for term 25-26, National Governing Council member of Indian Association of Structural Engineers, past Chairman of Civil Division Board of Institution of Engineers, Vice Chairman Builders Association of India, Vice Chairman of Kerala Management Association, Executive Committee member of Deep Foundation Institute India, and past Chairman of Indian Concrete Institute Kochi Center. In recognition of his contributions to the geotechnical engineering profession, Dr. Joseph was conferred honorary membership of the Nepal Geotechnical Society in 2024. Dr. Anil Joseph has done a lot of other works, and it is not easy to encapsulate or talk about him in 1 page or 2 page in a short time, actually. And he has been also involved in many demolitions, and probably known in India in a famous way as a demolition man of India for the extraordinary works that probably he is contributing towards the other sector in the demolition sector. And most importantly, whenever we meet him, he is so humble, friendly, and he has done a lot of charity works, and his through his company and on individual capacity too. Welcome to you, sir. Thanks a lot for accepting our invitation today. And I hope all the audience will take away something at the end of the day and enjoy his presentation. Learn from him. Thanks a lot. Well, we welcome you, sir.
Thank you, Engineer Kaushika, for the warm welcome. And it is a proud privilege to me be part of this 73rd Qcrete webinar series. And I thank you as well as Sharni Fernandez for the opportunity given. Also, I would like to place on record my thanks to Indian Concrete Institute Chairman Elson John, Shaiju Nair Secretary, and Liji Anna Matthew, the Treasurer. And also thank you, Chakravarti, for the introduction. And I will today talk to you about from distress to stability, geotechnical solution for infrastructure projects in complex ground conditions. So let me share the screen. Is the screen visible?
Yes, sir.
Yes, sir.
Yeah. So I will start this. So this is the topic selected for today: from distress to stability, geotechnical solution for infrastructure projects in complex ground conditions. So I will cover this in the four subheadings. Talk to you about what is complex ground condition, because in any load coming from any structure has to transfer to the foundation and to the soil. We'll discuss two case study. One is an embankment failure of a bridge at Mahi Talacheri bypass, and second is a case study for the protection of a gas pipeline during demolition by delayed delayed detonation technique for Supertech Twin Tower at Noida, and we will also look into some of the conclusions learned from the study. So, infrastructure development is increasingly expanding onto complex ground condition. Complex soils often lead to excessive settlement, slope instability, foundation failures. Many infrastructure failures originate from inadequate geotechnical understanding. So I thought today we will focus on that area, because anything, if you have a strong foundation, you can build very strongly on top of that. So what is complex ground? So complex ground is that soil exhibiting unpredictable or adverse engineering behavior. The common types are expansive soils, soft clays, collapsible soils, organic soil, loose fill, and reclaimed land. Distress in concrete abutment. Concrete abutment distress is very common. Damage or deterioration affecting bridge substructures caused by geotechnical issue, environmental chemical issue, operational issues like overloading from bridge deck traffic, construction errors. So these are some of the case studies where you can see that where the issues has come up. And common signs of distress in concrete pavements include cracking, movement, spalling and scaling, and leaching and efflorescence. Evaluation and testing methods include visual inspection, mapping cracks, dampness and alignment shift, non-destructive testing like rebound hammer, ultrasonic pulse velocity test, Haussel potential test, etc. Geotechnical check include monitoring foundation stability and soil erosion. So soils that show instability or low bearing capacity under load can be considered as complex soil, and the risks are foundation failure, excessive settlement, cracking of buildings. So this is a typical case, building which was constructed way back in 1170s, and it has started settling, and it went to such a degree that it might fall off. So this is the story of the Leaning Tower of Pisa. And I would like to tell a story. The Leaning Tower of Pisa has got a strong background in my career to pick up geotechnical engineering as my profession. When I was doing my MTech studies, my guide, Dr. M.D. Desai, was selected as a 10-member committee which was formed by the International Society of Soil Mechanics and Geotechnical Engineering to study how the Leaning Tower of Pisa can be rectified. So this story goes like that 1170s, they started up to 1300. They constructed 4 floors of the structure. This is a bell tower of the Pisa church. And then it started settling. After about 200 years, in 1300, they started another 2 more floors and put the bell at the top of that. The building started settling due to consolidation of the soft clay, and the settlement was going to such a extent that if something is not done, Leaning Tower of Pisa will collapse. So the people in Pisa contacted the Italian Geotechnical Society. They in turn contacted the European Society, and European Society referred to the ISSMC, where I serve now as Vice President for the Asian countries, to study and come up with a solution to this problem. So how they studied that? They studied in detail. They understood that the problem has to happen due to differential settlement. On one side they had sand, and the other side they had very soft clay. So sand settlement is immediate, whereas clay, the load will remain as a pore pressure and dissipates over the time, And as the consolidation process goes on, the building starts settling. So this was the reason why the settlement has carried, and it reached a stage that if it is not corrected, it will lead to a collapse. So this is the bell tower. In 1990, tower was leaning at 5.5 degree and increasing. So after that, the restoration work has been done to stop it from falling over completely. And up to 2011, they completed the scaffolding. So what they did was that the leaning tower was wrapped with copper wires, applied pressure, removed the soil from other side. The international committee worked on that and put pressure to bring it to a level of a inclination, and they came up with a degree that it can be made perfectly vertical. Once this idea of making it perfectly vertical came in, so there was objection from the people in leaning in the city of Pisa, because the revenue of Pisa is a small town in Italy. Pisa is a small town in Italy, and the revenue comes from the tourist who is coming to visit the Leaning Tower of Pisa. So what they did was that they did a voting, and the majority of the people voted that Leaning Tower of Pisa should remain leaning. So finally, they agreed to lean to 3.99 degrees, and it was stabilized in that area so that it is safe for the next 200 years. And strengthening was completed, and it was open to public. So this is a photo which I have taken during my visit to Leaning Tower of Pisa, which motivated me that engineering technology can be brought in to correct a problem which was created about 900 years back, almost 850 years back, and we can correct the problem. So that was the motivation for me to take geotechnical and structural engineering as my profession. The typical distress observed comprises of differential settlement, building and pavement, cracking of foundation and retaining structure, landslides and slope failures, and bearing capacity failure and ground subsidence. So need for geotechnical solution, increasing project complexity demands, detailed site investigation is needed, advanced analysis methods are needed, and ground improvement techniques. Objective is to ensure safety, serviceability, and durability. So this is the slide. And approach to stability includes site characterization and risk assessment, selection of the appropriate foundation system, ground improvement techniques, monitoring and instrumentation, and adaptive design strategies. So we have to move from distress to stability, and it consists of identification, diagnosis, solutions, monitoring. So shift from reactive repairs to proactive geotechnical design is where we have to move in. I talk about two case studies. First is the case study of the embankment failure of a bridge at Mahi Talacheri bypass. So this is the Talacheri Mahi bypass is expected to resolve the bottleneck drive on the Kannur stretch. 90% of the construction works were completed, and it is becoming the first 4-lane road in northern Kerala, which is in its final phase. With the opening of road, it will take only 20 minutes to cover between Kozhikode and Kannur, Muzhappilangad. At present, it takes more than 14 minutes to cover the stretch. And these were the contractors for the work, 4-laning. And some of the project area was waterlogged prior to start the highway work and was filled with borrower for construction purpose. Subsoil investigation study carried out indicated 12 to 50 meter depth. The end value of soil is almost zero, and rocky strata starts immediately. Without soil stabilization, construction is not possible in this stretch due to poor soil strata. So here you can see that, look at the end value. So this is the fill layer at the top, and these are zero end value, which shows that the soil is extremely weak. So it was referred to a consultant. So they suggested to go in for stabilization using geosynthetic materials and geotextile materials. As a part of the major bridge is to be constructed, embankment at the bridge is designed to construct to a height of 8 meters with provision of retaining wall at either sides of the main carriageway, in addition to the retaining wall for the service road portion. So this you can see this thing. And project vendors recommended stone column PVD and ground improvement technique, but the recommendation was withdrawn due to high cost of stone column and time consuming nature of PVD. As an alternative, spreading geotextile Geocell, after driving component piles of depth 7 meter to 11.5 meter was taken into consideration. The soil is assumed to have a settlement of 1 meter. After settlement, the geocell top will be at ground level after completion of the embankment. That was the concept of the design. So this was the design. So there will be a ground improvement at the bottom, then 200 thick GSB, then non-wove and geotextile, then 200 grid TGB, then GSB filling and 300 geogrid, and over that filling. So this was the design, and they expected that the pressure will come down. So if you can see the installation, we'll just see the photographs to understand it better. So this was the calculation which was worked out. So there is a pressure of about 16 ton per meter square, and they presume that after going through the improvement layer, it will reduce to about 2 ton per meter square, and soil will be able to stand that. So that was the concept, and they expected 18 centimeter settlement and bearing capacity to reduce to 1.4 ton per meter square was the calculation which was concepted. So this was the working drawing of ground improvement which was given, and this was the procedure. So this is the typical section. A coconut piles was provided at the bottom. This is the ground improvement which was carried out. This is the retaining wall which is formed, and the completion on the 8 meter filling was planned in detail. So this is the stages of construction. If you look in, first they have done that the driving of the coconut piles, you can see in the figure. Then 200 to 250 mm GSP blanket above the coconut pile. Laying of non-woven geotextile above the GSB blanket, and laying of TGB 200 geogrid above the geotextiles, and the laying of textile geocell above geogrid, and then it is filled with GSB, and this is the 300 biaxial compacted geocell filled with GSB, and top layer 250 mm GSB above ground, and then top layer 250 mm GSB above the geogrid, and M30 rough concreting was carried out. And after the wall construction, earth filling started layer by layer. The issues observed at site: the embankment work executed over the geocell stabilization layer up to a height of 6.5 meter, and a settlement of 10 centimeter was observed during the embankment construction. On 9 January 2023, a 20 mm gap was visible in joint of cross retaining wall at center line, and hair crack was formed in the embankment along the stretch. On 12 January, it increased up to 50 mm, and the cracks started increasing to 75 to 80 meter line. The cracks started forming. On 13 January, again the increase went on going up, and it was reached 11.5 centimeters, and the gap between the two walls started widening to 10 centimeters. So after that, the filling was stopped, and 14th January, the load becomes stagnant, and the geocell design is of for 14.5 ton per meter without considering the coconut pile, but it has failed in less than 10 ton per meter square. Further, 1.15 meter crust to be constructed over the embankment, and RHS embankment moved outer side, including the roll. So this is the site visit which is carried out by us along with the team from Professor Bhuminathan from IIT Madras. So it was a joint project between us and IIT Chennai. So this is the crack. You can see that, and you can see that how the retaining wall has widened out. This is the cracks formed on the surface. So here you can see how width and how the toppling is happening on the wall, and he can see that wide cracks formed. So this is the foundation level. So this is the mapping of the cracks done, how the cracks are forming, and we observed it for a period to understand what went wrong. So as part, it was decided to conduct 5 standard penetration tests using static cone penetration test, 4 vein shear test, 5 light cone penetration test, and 5 static cone penetration test to understand what is going wrong. So whenever you do, you have to do proper instrumentation. It is one area where India has to improve quite a lot. So here you can see that a SPT test being carried out, and so it was very softly we went for vein shear test to understand what is the behavior. And this is the static cone penetration test where the continuous sleeve friction and the capacity was monitored, and this is the light cone penetration test being carried out at site. So this is the SPT results, and we found that from 0, it improved up to 1, 1, 2 like that. So there is not much improvement where the bearing capacity has gone high. And here you can see static cone penetration test results, sleeve results, cone resistance, friction resistance, and the other behavior. And this is the light cone penetration test results. Again, not much improvement happened. So we understood that the geosynthetic layer was not that effective, and the consolidation was not happened to the fully, and it is very risky to get the loading done. Now, ground improvement techniques like PVD, sand piling, stone column, deep soil mixing, micropiling, etc., can be carried out, but we have to remove all the fill, again have to restart working, and it will take a lot of time. And it was that inauguration has to do in another 5 months' time. So we went for a numerical analysis of model was carried out using Plaxis to understand how the behavior was happening, and how since the coconut pile was there, some sort of stability was there, but the movements and cracks were increasing, and we decided that we will keep it like that, and a balancing surcharge will be formed on the other side, and we decided to go for concrete slab. That is, a new span was created. Since the soil failed in bearing, it is recommended that sheet piles or touch piles we used to create curtain wall around the retaining wall to prevent lateral movement. As already the bearing failure has happened, the compacted fill of 6 meter had been completed. It is very difficult and time consuming to adopt the technologies. Instead of further filling, it was recommended to provide board cast into Cyto DMC piles, terminating with adequate anchorage into the hard rock, and to have structural girder and slab till the height of the embankment is reaches up to 5 meter. Finally, we reduced it to 3.5 meter, and the remedial works have been completed and successfully implemented, and it is handed over now. The case study 2 is the protection of a gas pipeline during demolition by delayed detonation technique for the Supertech Twin Tower Noida in India. And this is Delhi. And this demolition of Supertech Twin Tower Noida is the second largest demolition by the implosion technology in the world, and where we used controlled demolition to bring the building down. And the biggest challenge was there was a live gale gas pipeline within the property, and we cannot stop the gas pumping, and we have to protect it when this huge massive structure of 40 floors is going to come down in a matter of 9 seconds. So that was the biggest challenge which has to be completed. What is implosion? Implosion is a controlled demolition technique where load-bearing structures are collapsed inward using strategically placed explosives. So the concept is, even though it's called implosion, we plan it such a way that we make a plan so that the demolition, the explosives is planned staggered in horizontal as well as vertical direction, so that the building falls exactly where we want, and we plan it in such a way that at one instant a particular mass of material come and hit the ground. So if you are talking about theory, it can be done in 6 steps. Step 1, survey the surrounding area, study the building plan, remove toxic substance, remove non-load bearing walls, drill columns, and step 6 is to detonate. So it's very easy when we look at the theory part, but when we actually do, you will have butterflies in your stomach. So you are not very sure whether you can press the buzzer or not, because it's a very important and challenging aspect. Vibration measurement plays a crucial role in the construction industry, and now the technology is advancing rapidly. Previously, we have light sensors, then the geophones came, then wireless geophones came, which can be picked up. Then the accelerometers were there in big use, and now optic fibers are being extensively, where any light movement is picked up, and sitting in a computer room, we will be able to understand what exactly the movements happening in the ground. Monitoring vibration during construction is becoming very important, and the influence of vibration on surrounding structure is one of the important factors considered during blasting demolition of high-rise building, especially in metros area. So this ground vibration is very critical and is monitored using technology. And the basic theory is that if you can control the vibration to less than 3.5 centimeter per second, that is the PPV. So when a mass come and hit the ground, the vibration starts forming, and it can be picked up with an accelerometer. And if the velocity is less than 3.5 centimeter, there won't be any damages. Whereas when it goes to 11.5 centimeter and above, there will be severe cracking of the building. So it's a back analysis being carried out. So we know how to control the mass to make sure that the particular mass is coming and hitting the ground. Now let us see a small video.
Good evening. The implosion dominates tonight's special edition of 10 Capital News.
We begin with the disastrous aftermath of yesterday's implosion. It's estimated a crowd of 100,000 people lined Lake Burley Griffin to witness history. What followed will be etched in the memories of us all for years to come.
Organisers had intended yesterday's demolition to be spectacular. They couldn't have imagined the traumatic effects it would have on the national capital. Instead of a safe, fully contained implosion, boats on the lake and crowds on the other shore were showered with debris, shards of steel warped and twisted by the force of the blast. The 12-year-old girl was hit and instantly killed, 9 others taken to hospital with minor injuries. Even today, no one could tell why the implosion turned into an explosion.
It'll be a painstaking and detailed investigation by the police. It's largely a matter, as you'd appreciate, I guess, of structural engineering questions, questions of physics, to determine the cause of the fatality and the injuries that were occasioned.
The girl was killed 480 metres from the demolition site, nearly 10 times the prescribed safe distance set down by contractors. But today, witnesses gave graphic accounts of huge chunks of steel thrown far further than that.
Bits of metal like that flying through the...
So you can see that what happened. A 12-year girl was killed in Canberra in Australia. This happened in Russia, so where they put only less explosive, and instead of the building falling, so the building remained like that. So generally, I work with a company called company from abroad, and where our lead consultant always keep telling, if you don't do your engineering properly, the building will stand there and laugh at you. So that is what we saw, that the building laughing at the engineers who did the job. Let's see a couple of more failures, so to understand how complicated this job is.
Oh!
So we saw that how complicated it is. Now coming to the case, this is a 7 lakh square feet building. It is in 93A Noida and the Greater Noida Expressways, 2 towers, initially planned for 40 floors. So completed 103 meter, 1 building, 32 floors, apex and CN 29 floors, and approximately 7.5 lakh square feet area. So this is the history. It was previously planned as a park area, and later on they made it into a 40-story building, and the neighbors went to court, and court was asked to demolish the building. So this is the building. You can see these are the 2 towers, and it is surrounded by full building. And to make matter more complex, there is this GAIL gas pipeline which is going within the property of the building. And this is that Astral building. So this is the GAIL gas pipeline. So we have done a plate protection and a berm and a geosynthetic layer and a rubber layer protection to make sure that it is happening. To bring this 32-story building of 103 meter, the time taken for us to do the job was 9 seconds. So this is the isochrome layout. So a 500 crore building was brought down in 9 seconds time. But for that 9 seconds, we did 6 months engineering. In the initial phase, I used to travel to Delhi once in a month. Later on, it became twice a month. And last 3 weeks, I was camping in Delhi to make sure that we are doing everything perfectly. So this is the sequence of the blast where we stagger it horizontally as well as vertically so that the mass coming and hitting the ground is controlled. And these are the primary floors where all the columns are blasted. So this is the dark, you can see. These are the primary blast floor where all the columns are blasted. And this is the secondary floor, only the shear wall are targeted. So that we control how the fall is going to happen. And this, like I told, it was done in everything in 9 seconds time. So this is the textbook. If you study that, edifice engineering Mumbai was the principles in this sketchbook: hammer and tongs, stash pit, burrowing in, taking cover, charging it up, lifting it rip. So these are the different stages how we implemented this job. So we also did pre and post blast of all the surrounding buildings, and made all those vibrations and reportory notes to the court. And CBRI was doing the comparison study and calculation for us. So you can see that even negligible cracks were reported to court, and also non-destructive testing was extensively carried out in the surrounding buildings. And it was all molded in, stimulated in like an earthquake wave motion. The blast wave motion was also stimulated, and the structures were modeled using ETABS. You can see that ETABS software to understand how the behavior is going to happen when the waves come and hit the building. So this is the three-dimensional model which you are seeing. And here you can see a small video where we saw that how the building will behave during an earthquake. This is the loading animation which you are seeing right now. And this is the video during the blast, how the building is going to behave, so that we ensure that as per the all code of practices of IS 1893, everything is within the permissible limit and everything is observed, and we do the prediction how it can be done. So this is as per 1893. Every displacement, loading, drift, everything is cross-verified. And 9-member team from Geostructurals and IIT Madras was monitoring all the vibrations and picking up. So these are the points where we have kept the geophones to pick the vibration, as well as accelerometers, in order to understand how the behavior is happening. And this is the team from IIT Madras. And here you can see that we are recording the movements through the accelerometer connected to the computer systems. So this is the vibration, and here you can see that the protection measures being carried out for the Gale gas pipeline. So this is the Gale gas pipeline. These are accelerometers put in. So this is the distance from the building, and here we are recording all the data through the systems. And if you can see that for the Gale gas pipeline, this is the buried pipe. So we have a geosynthetic layer, first a steel plate, then the geosynthetic layer, then vibration protection system, and protection, so that we stimulated in using the Plaxis software. So here you can see in detail how it is done. So I will just get into the analysis, but I don't want to take too much on the engineering design which was carried out. But you can see that this is the model, and it was stimulated, and we made sure that the vibrations are well within the permissible limit, and the pipeline is protected very well. So here you can see what exactly happening during demolition. When the material come and hit the ground, the vibration comes in and it is adjusted against that. So these are the different stages of the vibration, and these are all picked up, and we found that everything was within the permissible limit, and we were able to safely, successfully completed the demolition. Let us see a video on what happened on the 28th August 2022 when we went for the blast. So here you can see that before the building was there, after the building is no longer there. So it has gone, and we have recycled the material for roadworks, and steels were recycled, and also breaking was done to make C&D waste out of that for recycling purposes. And this is the video just after the blast where we are visiting the site.
सौरभ सबसे पहले हम आपको ये तस्वीर दिखाएं। ये आप मलबा देख रहे हैं, डेबरी में तब्दील हो गया। सबसे बड़ा मेजर कंसर्न था कि आसपास के स्ट्रक्चर, वाइब्रेशन और जो स्ट्रक्चर है आसपास का अंडर कंस्ट्रक्शन, उस पे इसका इफेक्ट क्या होगा। ये आईआईटी मद्रास और साथ में जियो स्ट्रक्चर की टीम है जो कि कोचीन से आई है, इन्होंने पूरा एनालाइज किया। ये वो टीम है, अगर जो आप पीछे एटीएस या फिर सुपरटेक एमराल्ड या फिर पार्सवनाथ देख रहे हैं, वो स्ट्रक्चर इंटैक्ट कैसे रहे, तो इनसे बेहतर कोई नहीं बता पाएगा, क्योंकि पूरी स्टडी का जिम्मा और पूरा इसे इंटैक्ट रखने का जिम्मा इन्हीं के पास था। क्या नाम है आपका? सौरभ सबसे पहले हम आपको
Yes, so this is some photo gallery. This is Professor Bhuminathan and Ramanath from Chennai, Bhuminathan from IIT Madras, and this is the Joe, the team who has done the blast. So this is the blast in Cochin where the team who has carried out. So conclusion is that complex ground is not a limitation, but a design challenges to be understood. Most failures stem from inadequate site investigation, oversimplified assumptions. Successful projects should rely on integrated geotechnical in approach, investigation, analysis, design, and also monitoring, because soil is such a varying element. Proper instrumentation and monitoring has to carry on. Selection of context-specific ground improvement techniques has to be used, and we have to make sure that we are coming up with the right solution. So this is the final video.
Under biscuit ka chadaayirunnu. Contract construction. Yes. Chalpa paneer. Chalpa paneer.
So thank you all for a patient listening, and I hope the system was informative.
Nandakumar, any questions are there? You can pick up and ask some questions if somebody has asked.
Yes, sir. Still, people are not started asking the questions. If any questions are there, good evening, everyone. If any questions are there, you can put it in the chat box. I'll ask to our Anil Joseph, sir.
Yeah. So these are certain challenges which I wanted to share, how the complications are there. So certain times we have to be very careful. And in fact, when you are doing construction, you have to make sure that we make proper concrete, because now we have been assigned a task to bring 230-floor buildings down, because it is only 5 years old, and due to the chloride content, we have to go for the demolition. So it's a big tragedy. So let us make sure that we make good concrete. And that's a message which I want to convey to you people, considering these different aspects, and also understand the generic behavior of the soil and decide on foundation what is needed.
Sir, if there are Nandakumar, if
so there is one question which I can read out. Some people leaving excavated area long time and SPC decreasing due to this reason. How to increase the SPC for this type of ground? So again, there are many ground improvement technique. Thank you, Hamarti, for the question. There are a lot of ground improvement technique, and based on what is the type of the soil, what is the SPT value, and what is the load we want to put up, we can work out technologies to improve. So ground replacement is a possibility, or like intrusion technologies like stone column or sand piling can be sought into based on the SPC we are looking for. If the load is more, we will have to go for deeper foundation.
Nandakumar, if there are no more questions, I think,
Yes, sir.
sir, if there are no more questions, I think we'll do the valedictory remarks by AVS Qcrete, sir.
Sir, good evening all. Engineer Abhilash Joy from ICI will deliver the vote of thanks. Kaushik sir, please allow him to use his mic.
Yeah, good evening, one and all. It was an excellent presentation. Thank you everybody for joining the Qcrete webinar number 73. Our topic for today was distress to stability, structural solution for infrastructure projects. He talked about ground movement as well as vibration due to implosion of buildings. We have a lot of them coming up in these days. And thank you, Anil sir, for the excellent presentation today. And it was an eye opener for maybe engineers in and around South India and across India. So thank you very much for your presentation. And I take this opportunity to thank Qcrete for sponsoring this event. And thank you, one and all.
Thank you, Abhilash, and thank you,
Anil Joseph, sir.
Yes.
It was really amazing to see some of the buildings collapse like that in 9 seconds. That is even though spectacular sometimes means it is a negative thing, but looks very spectacular. And I'm really amazed to see how much of work and planning and all you had done to achieve that kind of thing. Actually, that is I think, extraordinary planning and scheduling and so much of thinking. It is really mind-blowing activities that you have established and achieved. Actually, as usual, we are honored, and we thank you from Qcrete also for this. And we would like to have maybe in another time, maybe end of September or October, for another lecture. Thanks a lot.
Thank you. Thank you very much for the opportunity, and wish you a good evening, all of you. Thank you very much for joining. Bye.
Thank you, sir.